Welcome everybody to Apiculture Online, Hive Chat with NC State. My name is David Tarpey, and we welcome you to another installment of talking about bees and beekeeping and everything that there is to appreciate the love of our beloved honeybees. We have a really great program tonight. Just a reminder, we're going to be doing these Apiculture Onlines every Wednesday, the last Wednesday of every month. So last year when COVID first hit, we were doing them every 2 weeks. But now what we're doing is we're doing them every month so that we don't get too much Zoom burnout. But we have a really great guest today and some good topics to discuss. And so I'm just going to get started by first making some quick announcements. Again, we're going to the monthly format. You can go on to our website. There's a list of some of the future programs that are coming on, their topics, and the invited guests. We also have a couple online beginner bee schools. One of them has already passed. That was kind of a self-paced one, but we still have an opportunity for an all-day Saturday live through Zoom course for beginner beekeepers. And again, this is for non-beekeepers who are wanting to learn the very, very basics just in one day about what it would take to get into bees and beekeeping. We've also changed the date of our intermediate academy that was going to be held later this August. That actually got pushed to a Saturday, Sunday, the first Saturday and Sunday of October. So be on the lookout for an intermediate bees academy later on this year. This is something that we've done in person, 2 days, hands-on activities, as well as lots and lots of lectures and lots and lots of topics. They were really, really successful in 2019, but then in 2020, I think we were only able to do one before COVID shut everything down. So we're going to be renewing that. We're really thinking of those as kind of a booster shot to your beginner bee school, right? So it's not necessarily for the most advanced beekeepers, but it's for those beekeepers that have been keeping bees for 1, 2, maybe 3 years, and they just need just a little more extra depth and breadth of information about bees and beekeeping to keep them going and to keep growing their operations. So as always, we start out in the first segment, we start out on bees in season. And so in essence, this is just a segment where we talk about what you would expect your bees to be doing right now and what you as a beekeeper should be doing in order to assist them and to help them along. And so right now, kind of the end of February in the southeast of the US, it's been pretty wet. We don't really need a whole lot more rain. I don't know what it's going to do to the local ecology, but we sure are pretty soggy right now. At least in the Piedmont of North Carolina, it's been a very nice, warm past couple of 2 days, have been in the 60s and 70s. And so the bees have really been kind of waking up. You got to remember, though, that as a colony, the bees are really good when it's cold because they cluster and they are able to kind of save their energy, and they're not rearing a lot of brood or exerting a lot of energy, so they can stay kind of in this semi-quiescent state for a good long time. Warm is good because, then they can go flying and they can check to see if there's any kind of pollen or nectar resources out there, and they can, be active. But going back and forth is actually pretty darn stressful on the bees because, on days like today when it's above 70 degrees, I think, spring is here. So they can start brooding up, really quickly. But then once it gets cold again, then they might have to cannibalize some of those eggs and larvae because they're not going to be able to keep it warm like they thought they would if the weather was going to stay warm, right? So I think that kind of alternating temperature can be something to look out for on your bees to make sure it doesn't stress them out too much. How to do that without, being too heavy-handed? is watch for the activity at the entrance. So if you see a lot of flight, that's a good sign. If you see bees coming and going with purpose, some of them hopefully coming back with some loads of pollen, perhaps, if they seem to be kind of in and out straight traffic, then that's a good sign. The bees made it through the winter. They're, actively foraging, and that's a good sign of things. But if you see robbing, if you see different flight behavior where they're actually, kind of not going in and out with purpose, but they're kind of going in a zigzag motion, trying to find where the entrance is, that's usually a sign that the bees don't know where the entrance is and they don't belong in that hive. And as a result, they're trying to rob out a weakened colony or maybe even a dead out colony. And so that's a bad sign, and you want to make sure that you inspect that hive a little bit further to make sure that you don't have any problems like that. Right now, even though it still is technically winter and the bees are probably still clustering when it's cold and everything, they're still brooding up significantly. They try to anticipate the spring. They're getting cues from the environment that are really telling them that they need to start brooding up now so that they can go through 1 or 2 brood cycles before the spring nectar flow is really, in its full force, so that they have a larger population then. If they wait until then to start, growing, they're probably going to miss the boat. And so they're starting to brood up right now. But again, as we'll talk about in the timely topic, that can be fairly tenuous for them. Another thing that we're going to talk about in the next segment is how to supplement your bees during this time of year and how this can be a really, really tenuous time for the colonies. So we'll talk about more about the pros and cons of this, but right now you can help your bees by providing them with sugar syrup. Now, what you want to do, if you are going to provide sugar syrup, then you want to make, in essence, a thin syrup that is 1 part sugar to the 2 parts water. In the fall time, you want to give them a thick sugar syrup where it's 2 parts sugar to 1 part water, about as thick as you can make it, so that they can store that supplemental sugar water in the comb as honey, right? Here, the purpose is to kind of simulate a nectar flow that really helps to stimulate egg laying by the queen, which again allows them to start brooding up. Now, if the colony is already doing that, then you might not need that. If they already are bringing in some nectar, then they're probably going to be brooding up enough and you won't have to kind of stimulate them. But if you go in and you just don't see a whole lot of brood, but still a lot of bees, then providing a thin sugar syrup could be fairly helpful. Another supplement that you can provide is the pollen. So giving them a pollen patty, especially this time of year, that can be the limiting factor for their brood rearing, because they can store a lot of honey within the combs. But going into winter, they can store a lot of bee bread or pollen as bee bread, but they use it fairly quickly in raising brood, and so it can run out. And if they can't replenish it from a natural pollen flow, then you might again need to provide a supplemental pollen patty in order for them to get started on the brood rearing. But again, you don't have to do it. Just because it's this time of year doesn't mean you have to do it. So how do you kind of know the difference of whether you need to provide a sugar or a pollen protein supplement? And that is 2 things. First, just be very watchful on the outside for the foragers. If you see a lot of foragers coming and going with purpose, and about 25% of them or so are carrying loads of pollen on their hind legs, they're collecting something out there. You probably don't need the supplement. If you don't see a whole lot of bees coming back and forth, and you don't see a lot with pollen pellets on their hind legs, then maybe you might need to go inside and look for the stores. If you see plenty of stored honey, if you see plenty of stored pollen, again, you don't need to provide the supplements. But if they're pretty light because they've kind of gone through their winter stores a little bit quickly, and so they don't have a whole lot of stored food left, then providing a supplement to just get them through the next couple of weeks before those spring flows really start to happen. So again, as beekeepers, one of the things that we need to do is to help predict where the bees are going, not necessarily where they are, not respond to what they're doing right now, but then predict 1 to 2 brood cycles ahead, which is 3 to 6 weeks from now, so that you can do certain things to the hive and to the colony to allow their nest expansion or their nest contraction or whatever else they might need. So 3 to 6 weeks from now, the bees should really be starting their population growth. This is when brooding up now means 1 to 2 brood cycles from now means they're going to be a lot more populous, presumably if all is going right. So the hive might need some more space. That's something to consider, 2 to 3 weeks from now. So get those brood boxes, those frames of foundation, those honey supers, make sure that they're ready to go because spring is just around the corner. Again, the spring pollen and nectar flows should really be underway by, early to mid-March, depending on where you are in the Southeast. So with that, I'm then going to talk about our timely topic. So before I do, were there any questions? Is there any questions from the YouTube channel that anybody can see concerning what your bees are doing now? Can anybody see those?
What about pollen supplements in addition to sugar supplements?
So that's what I was saying. The pollen, so there's pollen substitute and then there's pollen supplement. So pollen supplement is where you actually have corbicular pollen that you've trapped from other colonies, presumably last spring, and you've just stored it in the freezer all this time. And you mix that together with sugar and you can make your own pollen patty that you feed back to your bees this spring before the natural pollen flow is on. Pollen substitute is where you're using alternative sources of protein, such as soy flour or baker's yeast or some of these others. And there's oodles of recipes that are out there that different people have tried. They haven't really been tested side by side necessarily for how well they work, but that's another alternative as well. But again, you only really need to apply that when they're not bringing a lot in and they don't have a lot stored. Another thing to keep in mind about those pollen patties is that small hive beetles love that, and they will raise thousands of small hive beetles on a patty of a pollen patty or a protein patty. And so you only want to give fairly small patties here in the Southeast, something that the bees will consume within a day or two. Otherwise, if you give, kind of a dinner-sized plate pollen patty to a, kind of volleyball cluster of bees, they're never going to be able to eat that within that period of time. And you might actually introduce problems within your colonies by having a small hive beetle outbreak. So just remember that. Thanks for reminding me about that, Aaron. All right, let's talk a little bit about the topic of tonight, which is problems to avoid during this winter-spring transition. I've already alluded to a couple of those by just simply talking about what your bees are up to right now. But let's go through some of the top issues and challenges that I can think of for bees and beekeepers. And again, others on the Zoom call, please chime in if I'm missing any or if I'm not explaining any of these adequately. So again, first and foremost, the challenge of this time of year is starvation. So, again, as the colony is going through winter, you have the cluster of bees, and it's ideal to have them start out below your major stores of honey. So if you go into winter looking like this, then the bees are going to cluster and then slowly move through the various frames, uncapping the honey, eating it, using that for their energy source. And then as they consume that, the cluster will kind of slowly move and then eventually up into the honey stored above the cluster, so that coming out of winter, ideally they look something like this, where the bottom box is kind of emptied of everything. They've kind of consumed all of that honey. The cluster's up here. There's some residual honey still around the cluster, but they still have enough to eat. So that's kind of the ideal of where you want to be. But the bees don't always necessarily do that. Sometimes they do something weird. Rather than, eating all of the honey down below here before moving up, they just move straight up. And so now the cluster is up over here. There's still plenty of honey in both brood chambers, but it's still kind of out of reach. It's not within, the cluster is not on those honey frames. So even in situations like this, even though there's plenty of honey, the bees might starve because they don't have easy access to it, right? If they're clustering really tightly and they're not right on the honey stores. So, sometimes they run out of honey where they just didn't go into winter with enough food stores, but sometimes they have the food stores, but just the randomness of the cluster and its movement, they still don't have access to it. So on warm days like what we had today, that's a really good time to go in fairly quickly. You don't want to belabor it, but you just want to go in, see not just where, if they have enough honey, but where it is in relation to the cluster, and make sure that the cluster is flanked and has sufficient access to those honey stores so that they can continue to eat the food. Another problem this time of year is chilled brood. So chilled brood happens because the brood nest is expanding, right? They're starting to brood up right now, but there's not a lot of bees hatching out because they haven't been raising brood for very long through the winter. And so as a result, the winter cluster has kind of been slowly diminishing and getting smaller as, the adult workers die off. And so you have a small adult worker population, but a large brood nest area. And so what happens there is that if the brood nest gets too big, so that during the cold nights, as the bees cluster and try to keep that brood warm, the periphery of the brood nest might get too cold to the point where the developing larvae can die. And so this is a picture from Don Hopkins that shows this really, really nicely, where, you have all of these different larvae that are kind of brown, decaying, decrepit. Some people can mistake that for a brood disease, but the telltale sign is that it kills larvae of all ages, young and old. When you have a brood disease, it usually kills them, kind of at the same stage of development. So if you see this, if you go into a colony and you see the periphery of the brood nest where, all of the larvae seem to be dead, but they're of different ages, that's probably because the cluster isn't big enough to warm and incubate that brood. And so try to collapse the colony down so that they can stay warm and keep that brood warm, rather than having too much space and too much of a brood nest to have to keep incubated. Another challenge this time of year are when queens can kind of prematurely fail. So, you have a queen, she laid all last year, she made it through the winter. And so as they're starting to brood up this spring, sometimes older queens can start running out of sperm prematurely before we get to the spring. And so if you see things like this, where you see these domed brood cells within the where the worker should be, those are drones from unfertilized eggs. And so that's a telltale sign that the queen is kind of starting to run out of gas. And so this can be a problem if she's not laying any workers. If you only see kind of spotty one or two here and there, then they'll probably be able to make it to the spring, in which case they'll probably naturally replace that queen because she's running out of sperm. But if you don't see any workers and all you see are these drone cells within the comb area where the workers should be, that can be really problematic because it's going to be pretty hard to find a queen for sale this early in the this late in the winter or early in the spring. And so this is something where you might have to take some kind of triage action, like uniting it with another colony, or, you know, calling around to people pleading to see if they have any extra queens, or, you know, purchasing one from Hawaii or something like that where they have an earlier season. But the supply right now is really, really limited for newly mated queens. Another thing to be on the lookout right now, unfortunately, is a lot of dead outs. Again, you can do everything right as a beekeeper, but still things go wrong. So just remember that. And going in and identifying colonies that have died over the winter, despite your best intents and efforts. This happens to the best of us. And so going in and identifying that. So here, you know, here's a cluster from a dead out where these bees are actually, they're all dead, but you know, it's the last cluster. It's only about a fist size or so, where the workers, you see their butts sticking out of their cells because they're trying to keep warm. These other bees are trying to keep warm as well, but they just don't have that critical mass anymore in order to maintain that heat. And so unfortunately they all perish. The old adage of beekeeping is that colonies don't freeze to death, they starve to death. So that can only happen if two things are true. One, they have sufficient honey stores, and two, they have enough bees to maintain that critical mass that can generate that heat and make it through the winter. A lot of times in these dead outs, you know, they're not very pretty. You often see kind of mold growth on the combs and, you know, things like that. Some beekeepers often blame these molds for killing off the colony, but actually it's the other way around. The colony had died off, and so these molds are just kind of environmental molds that take advantage of that situation. They're not pathogenic in any way. And in fact, you know, you can take those, unless it's like really, really nasty, you can take those and you can put it in a strong colony next spring, and the bees often just clean that up. It's really important, though, to make sure that you take any dead outs from your apiary and you go and you try and do an autopsy on the colony to see kind of why they died out. Did they die out of starvation? Did they die out, you know, from disease or other issues? And then you store that equipment, you clean it up appropriately for whatever the reason was. You store it so that you don't have other colonies coming in and robbing out those honey stores and potentially passing diseases or other problems around. So make sure you remove the dead outs from the colony or from your apiaries and don't let them linger. Another challenge this time of year, as I've already alluded to, which is overstimulation of your colonies. So here's a kind of a good example of that, where here's a colony that's pretty much bursting at the seams from what I can tell, right? They're, especially for this time of year, and they have the kind of fondant on it for the sugar, and they have a protein patty right here as well. I don't think these bees need to be stimulated for anything, right? This is really kind of overdoing it, and in fact can cause problems down the road. If you overstimulate them, they're going to become honey bound. They're going to totally extend their brood nest, and probably be swarming way before you know it, which is the sixth and final problem, which is splitting or having your colonies swarm too early. You know, if you really want to get ahead of the game and you think you have a really strong colony right now, and you want to get ahead to make sure they don't swarm, and you go ahead and split them, well, if they're going to raise a queen, who are those queens going to mate with? They're not really raising drones right now, or at least if they do, the population of drones is not going to be really, really high. So, you know, there's such a thing as doing things too early. You need to wait for spring to fully get here. And so you don't want to get too eager or have the bees get too eager for themselves. So premature splitting is also another thing that you need to be careful of this time of year. Anybody else on the Zoom call that wants to chime in on any of those or other points, challenges this time of year?
Dave, it's probably a good time to think about what you're going to treat for mites this spring also before the honey flow.
So that's a great point. Actually, Lewis had mentioned that before the recording here about you're always going to want to be monitoring for Varroa mites. And even though their populations really hit their height in the late summer and fall, you're going to want to make sure that they are relatively Varroa free coming out of winter as well. I mean, it's a tough time for the Varroa to overwinter, but they still do it. And so the thresholds for a problem are extremely low this time of year because they'll have all season to grow up their population and become a problem. So if you have more than 1% of Varroa mites, in February, March, that means your colonies are going to have problems starting, May, June, if not before. So it's definitely something to keep an eye on. Again, hopefully the mites got knocked down from the winter and they're not a problem, but the only way to know that is to monitor for them. Do a sugar shake, do an alcohol wash, do some sort of monitoring program. If you don't know what we're talking about, go back to our YouTube channel. We have some previous recordings about not just how to monitor for your Varroa mites, but also different options for controlling them as well. Thank you, John. Any other points to bring up?
Yeah, I just wanted to underscore that you're correct. The safe threshold is less than 1 mite per 100 bees this time of year.
Yep.
And I have found colonies in my yard in the past at 3 to 5% in February. And if you don't catch those early, that's going to really cause a problem for your apiary and other apiaries in your neighborhood.
Yeah, and it can be just one colony, right? If you have one colony has 3% right now, that's going to die out soon. All your other colonies, the mites are going to spread to those. And so it's not, it's a communal problem, not just a singular problem, right?
Right. And so if you can catch them early and you'll have some time to get a treatment on before the nectar flow.
Yep.
And so I'd encourage everyone to get out there. I'm sure that there are outliers out there with high loads. The trick is finding them, and we can't find them unless we monitor. So
can't find them unless you look.
Do that work.
Exactly right. Thanks, Lois. Anything else that we're missing before we introduce our guest of honor tonight?
I have a question, David.
Sure.
What is the most common treatment you guys are using for Varroa mites?
So that's a great question. I think there are many different control measures, as you know, that are out there. I think it really varies. I mean, we have a very, very large population of beekeepers in this region, and their philosophies range accordingly. And so I don't think there is kind of a number one or an only treatment that different beekeepers use. I think, as usual, following the integrated pest management for Varroa, it's good to mix those different control measures up so that you're not using the same one over and over again.
Okay.
But does anybody have any comment? Like, what's the ones that people tend to use the most?
David, you hit the nail on the head. Most of the peak bees I'm looking at, they're the best looking bees, or people are following that method, and they are switching between oxalic, Apricot gel, formic, and the Amatraz product.
So the Apivar, yep.
And what would be the estimation of the number in average, just like really roughly, the number of treatment per year you guys do?
That's a
2,
great question
3,
too.
Or more?
Well, we never really have what I would say is a true, well, depending on where you are in the state or within the region, they probably always have at least a little bit of brood. So I think that's different from more northern climates where they can go broodless and, so I think there's less pressure, but that also limits the number of options. Like oxalic acid, for example, that's can only be used in a broodless period. And if we have kind of a short, and or warm winter, that's not really so much of an option for a lot of beekeepers around here. So, but if you have an early control mechanism, then you might not need as many applications throughout the season, right? So do you guys want to say what's the kind of average number that you guys tend to see across the state? It's probably fewer up your way, Lewis, right, in the mountains than it is down your way, John, by the coast?
I don't know. I can only speak for my apiary, but in my apiary, it's probably a little more than 2 per year. So probably every colony is going to get 2 treatments. They'll get an apivar in the late summer and oxalic acid in December. And it's based on my early spring monitoring. Some may get either apivar again or oxalic acid if it's warm enough. Right. So I would say 2.5 treatments per year would probably be a good guess.
Yeah, but that's also you have a little more of a winter up in the mountains than down where you are, John, by the coast, where it's darn near subtropical, right?
Yeah, and we have. I mean, I saw queen cells today that were just started. If that tells you the difference between me and Lewis, and which means they'd probably be swarming in a week and a half to 2 weeks because it's going to be warming this week. But most of the smaller apiaries and the hobbyists probably are doing close to 2. Yeah. Whereas the commercial guys who have a little bit more pest pressure because of the numbers of hives in the yards, they're doing some of them 3 or 4, and of course they're really pushing their bees. Yeah. And some of those guys are getting 2 seasons out of their bees with the almond pollination. Yeah. So it's a different model.
Yeah, and that's what I was saying to Mohammed earlier, that we have a wide variation of beekeepers that are keeping their bees for different reasons, right? So I think that explains why there's variation in the control measures. Go ahead, Don.
There's an awful lot of over-reliance on the oxalic treatments. And they're going way off the prescription as far as the label is concerned on that.
Yep.
The most effective treatments are probably still the apivar. The Apiguard is useful here because of the temperature constraints on the formic. But probably the most popular would be the Apiguard and the apivar.
Yeah. Okay.
And what about the formic acid? Do you guys use the formic acid?
What about formic?
Do you guys use the formic acid?
When we can, but we have a very narrow window to be able to use it because of the temperature.
Okay. I see.
Yeah, I think the ceiling of that was it like 91 degrees or something like that? It's only in the 90s. And it can often exceed that for much of July and August, or even outside of that. And so it can volatilize way too quickly, and it can bird brood and cause more problems than it helps. And so, yeah.
I know when it was first registered, we used it according to label, but I don't know that David Vanderdusen took into the account the humidity down here.
Yeah.
The temperature was right, but the humidity was so high that it just sort of hung in the hives and ran.
Yeah, no, that's right.
Like
that's right.
Well,
thank you for that discussion. And let me go ahead and introduce our guest of honor who's already joined the discussion. It's Dr. Mohammed Alburaki, who is a new research scientist at the USDA Agricultural Research Service in Beltsville, Maryland, kind of the mothership of the USDA. And he started just under 2 years ago, but he came to the USDA from a postdoctoral position at the University of Southern Mississippi, and then before that, the University of Tennessee. But he got his PhD, and where he's from is actually from France. And so Mohammed has really been all over, and he's done a lot of really nice work on kind of landscape effects on bees and bee health. as well as you've really kind of dabbled in lots of different areas. And so I'd like to introduce you and have you share some of the research that you have done and what you are currently doing at the USDA.
Sure. Thank you very much, David, for having me. I just want to correct a little bit some small detail. Originally I'm from Damascus, Syria. I grew up in France and studied in France, just
Okay.
like this. So yeah, I joined the USDA less than 2 years ago, and before that, I was doing a postdoc at the University of Southern Mississippi, where I was particularly interested in working on the gene regulation and the effect of pesticide on gene regulation on bees. And before that, I did one of my best postdoc years in Tennessee, the University of Tennessee.
Mm-hmm.
This is where we were working together,
Yep.
David. And it was more on understanding the effect of the landscape composition and the pesticide use on the honeybee health, as well as the productivity of the bees. And that was relatively a long and fruitful
And so
project.
what did you find? What was the main conclusion of that? It's actually a couple papers, but what was the main
So the main
kind of take home of that work?
Yeah, I think this work was very interesting. The main conclusion is that we were taking bees and putting them in different landscape composition where we have high ag area, moderate ag area, non-ag area, and mixed ag area with urban activity where you've got
Yep.
like backyards, houses,
Yep.
and the city basically close by. The main conclusion is that bees need to be close to crops. Basically, you can't just dump them in a forest and say, oh, okay, there is no pesticide there. You ladies, you will be fine there.
Yeah.
That's not working. The other extreme option is that when you put bees in high ag area, monocultural area, where you just have like corn or soybean or other type of crop or cotton or depends on or sorghum, or depends on the area where you are.
Yeah.
And once the flowering season is off, they have absolutely nothing, and they start to consume what they've stored during this short period of time, and then they run out of food, and that's a second problem.
Yep.
So in Europe, they have this mentality of starting growing, and I think the USDA did it, the pollination plots.
Yep.
The program, I think you are aware of that, David, where they were asking farmers to sow plants, wild plants, to basically give bees some forage in the time where they run out of any option in the high ag field. So basically, it's a balance at the end of the day. It's very important to understand that the pesticide issue is not very scary because we've analyzed. It's important.
Yep.
It's one portion of the problem we have.
Yep.
But it's not everything, you know. Yep. So just escaping from the pesticide and going to forest, your bees are gonna starve, basically. Mm-hmm. Like that's the conclusion. Mm-hmm. And one impressive thing that we found is that if you put them in a moderate ag with mix, you've got some ag, mm-hmm. you've got some urban activity, you know, mm-hmm. plant in the backyard, flowers, mm-hmm. like some diversity of flowering, they will have the ability to survive better, have a flowering period across the year, and they will collect pollen much more diverse yep. than what they see in any of the other landscape composition that I've just explained.
So a consistent, diverse, prolonged diet is good for the bees, but having too much of a good thing for too short a window period of time, that's not gonna. They're in it for the long haul, right?
So absolutely, I think the word that we need to keep in mind here is sustainability.
That's right.
Like you need source that will sustain the bees throughout the season, rather than like, okay, just having one big dump of nectar, and then ladies, you have to wait for quite some time, or a month or 2 months, and then having so I in my opinion, the two words that we need to keep in mind is sustainability and also adaptation. Adaptation is very important. Adaptation is really a different context here, but in terms of landscape, and adaptation is more genetic, the genetic side of what type of species or subspecies we are raising or we have, but that's completely different issue. But sustainability in the forage is extremely important, and it's the major problem, in fact, because we didn't see an effect, a serious effect of the pesticide, in fact. We had some events of like toxicity, acute toxicity, but that's it. It was not very significant, in the setup of that study.
In the greater scope of things, it's really the entire environment is really what the bees are responding to. Yeah. So are you continuing that work, or are you going in a different direction now that you're in the USDA, or what's up? What are you doing new?
So I think we are going to continue that type of work, because so currently my lab is studying the effect of biotic and abiotic stressor on bee health. And it's a big title, so it has a lot of stuff in it. But we are going to orient a little bit more with more focus on the queen quality and performance, as well as adaptation, and how those mainly there will be abiotic stressor, particularly the pesticide issue, and the forage availability, sustainability of the forage also, and the effect of the environment on the colony. And when you talk about colony, basically the main focus is the queen and the queens, but you need to look at the health of the entire population, because the queen cannot survive without her entourage, let's say. So it's a health of one single community that you need to keep in mind. But and we are working on different topics, hopefully. But this will be mainly the major focus is the queen quality and performance, and how we can improve that, and how we can find what are the reasons basically that we have queen failure, we have queen with poor performance. And that's a big title, because the process of raising queen and the study of the DCA, where is the problem exactly, why we have to requeen every single year, and this practice that we have. So a lot of question here.
Yeah, explain that a little bit, because I think that there's a lot of new beekeepers where this may be their first season, or other beekeepers that they've never known that queens are supposed to live more than a year. So explain kind of the history and the arc of queen biology, and why we're considering it a problem, and not just the new normal.
Yeah. So if you look at, so you have to address this question, you really have to look at it within the perspective of within the United States of America, so within our country, and outside, how outside they are doing the thing. So the main thing to understand is that all the bees we are raising, all the subspecies we have here, or even the Apis mellifera species is not indigenous from the US. They've been imported from the old world. And now here is the practice of beekeeping, the industry of beekeeping is based on requeening and productivity, and as I want to produce as much as I can, as quickly as I can. In, let's say, in Europe or in France, or where I used to work, or even in the Middle East, because I practice beekeeping in the Middle East, in Damascus and Syria, and in Canada, and also in France. The approach is more conservative, let's say. So they tend to, but why it is like this? That's the major question. It's like this because it is a bee which is indigenous from their area. So it's very well adapted to the climate, to the geographical location. They have different haplotypes, they have different ecotypes. So they want to conserve that and improve on it. So queens tend to be adapted to the yield of the forage and the nectar yield in the area where they are. And beekeeper will not requeen like randomly. usually.
Mhm.
So the
Mhm.
process of buying queen, putting a package together, artificially constructing a small start is not on. It's very limited in those areas.
Yeah.
Here for us, it's the main practice, and
Yeah.
there's a price to pay once we
Yeah.
want to intervene, like in and change the nature and the biology of the population of bees. We'll have to deal with the consequences, and that's what we are seeing now. We need to requeen each time, and we don't let the bees. Maybe, I mean, there are different causes, but some of them, okay, the queen is no longer productive the second year,
Mhm.
or the queen will be superseded by the bees themselves because there is not a good communication,
Yep.
or something is wrong because of that
Yeah.
mix.
Yep.
So this is a complex issue that sooner or later will need to be addressed.
Yeah. So would you say then that kind of that European model of kind of like, so the US it's more like fast food, fast beekeeping, right? Whereas in Europe, it's more slow food, slow beekeeping. Would you say that that kind of is more of a sustainable model then, to use that term that you were saying before?
So, I think it is, but at a certain extent, at least we can start by state. That's one of the area that I would like to tackle in my program on the long run. We want to conserve, like, we have different climate in the US. We can't just bring queen from California or from Hawaii. And what type of subspecies we are bringing? Are we Carnica, Ligustica, and our recent
North
study
American
was
mutts. That's what we have. We have just a total genetic admixture of pretty much everything, right? Like, so that's one of the things where you may have these different genetic types that are well adapted to their specific region in the old world, but over here everything's been so mixed up. What are your thoughts about how we might be able to harness those kind of local adaptations, to use that other term that you used, even though they're kind of not kind of naturally indigenous to here?
So that is easy, because we have to go by the climate first. The climate is the most important thing.
Right.
And we know the climate zone in the US, we have 4 or 5 different type of climates. And we need to see what would be, you've got the North Mediterranean lineage, for example, the sea lineage. This is the subspecies mainly represented by Carnica, located in the north of the Mediterranean Sea. The weather is completely different than what you have in the northern part of France or in Netherlands. So here in the US, we have to at least try to bring those subspecies and give them a chance to locate in the area that resemble somehow to their original location. But that will require first a screening, a large scale screen. And that is what we've started in our lab.
Okay.
Hopefully we'll be able to collaborate with you on that, sure. David. So we need to understand what is the genetic background, what type of haplotypes we have here in the US. Right. I obtained some study to really see what we have. I need more samples, of course, but after screening and having an idea, how is the distribution, where are the queen producer, what they have, what is their maternal lineages they are working with. And we've seen a recent study describing that the genetic background is shrinking of the population of the US because we don't have blood coming from outside. We are working in a small chunk to begin with. And I think Dr. Sheppard would agree with that point too. Steve Sheppard from University of Washington State. So we need to address that. We can wait, we can find temporary solution, but on the long run, we need a better, more sustainable solution for this problem, because it's going to increase day by day and year by year. So we need to help bees to really find the better adapted environment for them.
No, totally agree. Now, usually this last 15-minute segment, we have just an open Q&A where we invite everybody who's watching on our YouTube channel to type in their questions for our guests and just any other questions that they might have. But again, we're having some sort of technical difficulties with the YouTube chat, and I don't think any of us can actually see anything. I don't know if anybody's actually typing anything in. So apologies that we're not able to read those off and to discuss those. But we'll just try and keep the discussion going based on everything that Mohammed's been talking about here. And I'll open it up to the rest of our panelists here on the Zoom call if anybody else has any questions for Mohammed and some of the work that he's been doing.
Yes, Mohammed, I'd like to ask you the pesticide use difference between here and Europe. For example, like the neonics.
So in terms of legislation in Europe, I'm not very aware of what they have, but I've read in the news that they've banned the neonics long time ago, mainly on the sunflower, and now they and then after a few years, that was in 2000, maybe 8, if I'm 8, 9. The EU completely banned the use of the neonics, and the battle is like huge on this stuff. They started on the sunflower and then on the corn, and then they on everything.
Yeah.
Now they've reversed, and it's not a single unit. You've got like countries within the EU. Not all of them comply usually with the EU recommendation. I don't know how they enforce that, but at least in France they've banned the neonics. That is what was from 5 years ago. Recently, I don't know.
And how have the losses looked since that time? Have they dramatically gone down? Have they kind of stayed the same, or like what's been the result of that?
That was one argument. Yeah, that was one argument I heard in Apimondia one time. The guy was saying, "Okay, you banned the neonics, and the population are still decreasing. So I don't see the reason why. I mean, it's not effective. Basically, it's not the pesticide. It's not because of the pesticide." And this is kind of large argument, in my opinion, I would say, because we should know that neonics, especially the imidacloprid and clothianidine and the third molecule, the thiomaxin, are extremely toxic. Like imidacloprid is 13 ppb, the LD54Bs. So this is a really, really, really small residue. Yeah. So, but at the same time, you have to look at the both side of the equation. Farmers, for their control of pest control and crops, they need it. But I would say it's in Europe the regulation are much more strict when it comes to pesticide application than in the US. This is my personal observation.
No, I think that's a pretty well-known fact. That
I was just curious that being one of the effects of the shorter life we're seeing on queens, because in my earlier days of beekeeping, it was nothing to have a queen in your bee yard that was 3, and I actually had some 4 years old, marked queens, and of course they'd always swarm the 4th year if you did. But now if you can get 2 years out of a queen, it seems like you're doing good, and this is to be an issue across the population.
Yeah, I think factors are numerous, and maybe definitively the residue in the royal jelly, residue in the wax. The queen is crawling on the wax all the time. She's fed by the worker bees around, and there are some recent studies showing that you've got residue and pesticide in the royal jelly coming to the queen. So even small, tiny amount are adding up, and that would be also with other reason, of course. That would be a reason for the why the lifespan of the queens are shorter. It could be a problem within the queen themselves, like biological problem due to all those stressor. But my personal opinion is more the big portion would be adaptation, from my point of view.
Any other questions for Mohammed?
Steve, you mentioned Steve Sheppard. He and Nathan Schiff, gosh, when was it? About probably 25 or 30 years ago, came down here in the mountains, and they were finding some of those isolated populations back then.
Yeah.
That was before the mites, though.
Wow.
Yeah. Some of them might still be around.
Is Steve that old? I don't know.
Yeah, he was. First time I met him, he was working up where you are now, up in Beltsville.
Yeah. Steve. In fact, Steve was I had the honor to have him in my PhD jury member difference. So he was there in France when I defended my PhD. He was a jury member.
Yeah. But yeah,
That's great.
they did find some isolated populations here in the mountains here in North Carolina.
Mhm.
Yeah, and I think there's still isolated populations up there, but again, they probably need to be tested again.
Yeah.
In much the same way, because these populations can fluctuate, especially after the arrival of Varroa. I think it's kind of still an outstanding question to see if they have persisted through the arrival of Varroa or if they've been recolonized in those same rural areas and perhaps even kind of readapted. So I think those
That would
are
be good, yeah.
some ongoing questions that would be interesting.
So getting advantage of the natural selection of those isolated
Yes.
population, maybe some traits would be fine there.
Yep.
Resistance to Varroa or else.
Yep.
Yeah.
Yep. Exactly. Well, again, I want to thank you, Mohammed, for joining us in a really wonderful discussion. I want to remind everybody that we're doing this the last Wednesday of every month. So our next Apiculture Online is going to be March 31st, when we're going to be talking about a very timely topic that time of year, which is swarm prevention and how to walk that line between having the colonies big and thriving, but not so big that they're going to leave in a swarm. And we're going to luckily have our guest interview is going to be Ramesh Sagili, who's my counterpart, the extension apiculturist out at Oregon State University. And he's done a really lot of great work on nosema and nutrition, much like Mohammed was talking about this evening. I apologize again for the technical difficulties and folks not being able to type in their questions, but hopefully we'll have that resolved next time. And again, thank you for your attendance.
Thank you very much. See you guys.